All right. Today we're looking at the introduction to chemical bonding. Introduction to chemical bonding. All right. So without wasting much time, my name is King Solomon, and this is the Studies with King's Lessons. If you've not subscribed to this particular channel, you can do so. And we study a lot of WASSCE concepts, university concepts, syllables over here, so that you'll be what? You'll be well abreast with certain concepts. All right, so straightforward with chemical bonding, the chemical bonding. Now, when we say a chemical bonding, what do we mean? A chemical bonding, the first thing that should come into your mind is that we are looking at what? One, a force of attraction. So anytime you hear the word chemical bonding, you are looking at what? A force of what? Of attraction that holds atoms, ions, or molecules together to form what? A chemical substance. So you are looking at a force of attraction. The keynote is what? Holding atoms, holding ions, holding what? Molecules together to form a chemical substance. To form a chemical substance, such as the molecules or what? Or compounds. All right. So now, atoms bond in order to one. So the reasons why atoms bond, okay, the reasons why atoms bond, or the reason why we have bonding reasons, is that one, they want to achieve a stable electron configuration. They want to achieve a stable electron configuration. That is one of the points. That is usually we are looking at the noble gas configuration. I've already done this in previous videos. The noble gas configuration, where, for instance, when you check your periodic table, when you look at argon is what? A noble gas. So after argon, okay, after argon, you have other elements like potassium and calcium. So argon has proton number of what? 18. So if I want to write the electron configuration for potassium, I can do the. All right. So if we have argon, we have its electronic configuration as 1s2, 2s2, 2p6, 3s2, 3p6. Okay, so here this makes up to what? 18. That's 2, 2, 6, 10 plus 2 plus 6, 18. So now, if you want to write the electronic configuration for potassium, it will have been 1s2, 2s2, 2p6, 3s2, 3p6, and the last one, which is what? 4x1. Which is 4x1. But in using the noble gas configuration, all of this from here to here is for argon. So you can just write K is equal to what? Argon, and you bring what? Your 4x1. This is how you write the noble gas electron configuration. So one of the reasons of what? Chemical bonding is to achieve what? A stable configuration. And in achieving a stable configuration, we are looking at the transfer of what? Electrons from one point to what? To another. That is the need for what? Chemical bonding. Okay, that is the need for chemical bonding. But I've taught you how the noble gas configuration is. So to achieve a stable electron configuration, a typical example is, for instance, if I have a sodium chloride. Okay, if I have sodium chloride. Now, this sodium chloride is possible because one, sodium has, according to the Lewis dot structure, okay, sodium has 10 core electrons and 1 valence electron, and chlorine has 10 core electrons and 7 valence electron. So according to the Lewis dot structure, so let me write it here, the Lewis dot structure. This is what it says. It says always 1 represents the chemical symbol. So the chemical symbol represents the core electrons, And 2, use dot. Use dot to represent the valence electron. Yeah, so that is the Lewis dot structure. So we use what? Chemical symbol to represent the core electrons, and use dots to represent the valence electron. For instance, if I want to write, let's say calcium, the Lewis dot structure for calcium. Calcium has, if you are using the normal connotations, is 2, 8, 8 what? 2. That is, it has atomic number of what? 20, 282. Now from here to here is what? The core electrons, and 2 is what? The valence electron. So when I want to write calcium in a Lewis dot structure format, I just write the calcium. The chemical symbol here represents all the 18 core electrons, and I'll just use dot to represent what? The 2 valence electrons. That is it. So this is a typical example for calcium. So with what we are looking at here, for the sodium and the chlorine, okay, in achieving the stable electronic configuration, this is for the sodium, this is chlorine. Okay, chlorine has 7 valence electron, sodium has 1. So for it to be there, for there to be a bond, this one must bond with this one, okay, to achieve the octet. So sodium and chlorine, they share what? Their electrons together. This is a typical example of an ionic bond. When we get there, you understand it more. So this is what? The sharing of electrons, or this become what we call the bonded pair electrons. Okay, so the reasons, one reason for chemical bonding is we want to achieve what? A stable electronic what? Configuration. Because this one is single and this one is single, it makes the elements over there, or the atomic nature, unstable. Unstable. All right. Now, the second reason for chemical bonding, is to reduce potential energy. To reduce potential energy. All right. So the reduction of the potential energy leads to the third point, which is what? Increase stability. Increase what? Stability. So I'm going to explain these two together. I'm going to explain these two what? These 2 points what? Together. Now, why does chemical bonding reduce potential energy? Now, we should first of all understand that 1, atoms are unstable. Atoms are unstable when alone. Okay, they are unstable when alone. Why? Because single atoms, especially metals and non-metals, are usually unstable because of their what? Their outer electron shells are not full. So atoms are usually unstable because what? Their outer electron shells are not full. Unlike the noble what? Gas what? Electrons. Their outer electron shells are what? Are very full. That was the first explanation I was giving in the first point. So now, because the outer shell electrons are full, especially with the metals and the non-metals, what happens is that they have high potential energy. And this high potential energy leads to high energy state. Okay, you're a chemistry student, so you should know the terms very well. This high potential energy leads to high energy state, which makes the atoms what? Unstable. Do you get it? Which makes the atoms what? Unstable. But atoms in their normal nature, they desire a more stable what? Configuration. So what happens is that when we have a chemical bonding, when atoms bond with each other, they are able to reduce this potential energy. Okay, and in as much reducing the potential energy will increase what? The stability. Are you getting it? They're able to reduce the potential energy and increase what? The stability. So what happens is that when atoms bond to reach the octet, okay, this is the word octet. So there's something referred to as the octet rule. So when atoms bond to reach the octet or duplet, so when we say octet, we are looking at the 8 valence electrons. We are looking at the 8 valence electrons, and the duplet, that is, it's for hydrogen and helium. Okay, so if you write your electronic configuration, you see you have 2, 8, 8, 2, going there about 8, 8, 8. So this is the octet. When the outer cells are full, they are 8. But if you look at for hydrogen and helium, they only has 2. Hydrogen is 1. It is unstable because it needs another electron to be 2. And helium is what? Stable because of what? The 2. Because helium is what? A noble gas electron. It is very stable. So for hydrogen and helium, they deal with the duplet. But other elements, aside hydrogen and helium, deals with what? The octet. That is the 8 what? Valence electron to become full. So what happens is that when they achieve this, are you getting it? When atoms bond, they achieve either the octet or they achieve what? The duplet. So when this is achieved, what happens is that the potential energy now decreases. Are you getting it? And in turn what? Increases what? The stability. And in turn increases what? The stability. So this is the reason why bonding happens naturally. I get it. This is the reason why atoms, when they are there, they want what? Bond. So it's the reason why bonding happens naturally, for them to achieve the octet, or they achieve what? The duplet. Or they achieve what? The duplet. All right. So now, with the introduction, the last one I'll do over here, and we move on, is when we say chemical bonding, basically, in the broad perspective, anytime you hear chemical bonding, in the broad perspective, it is divided into two. We have the interatomic bonds, and they have the intermolecular bonds. So anytime you hear chemical bonding, these are the two things that come in mind. One, the interatomic bond, and two, the intermolecular bonds. So when you say an interatomic bond, we are looking at the strong bonds that joins atoms together. Are you getting it? We are looking at the strong bond that joins atoms together. And when we say intermolecular bond, we are looking at the weak forces acting between molecules. So we are looking at weak forces acting between molecules. That is what the intermolecular bond. So a typical example is that if you look at the interatomic bonds, look at the interatomic bonds, we have one, the ionic bond, we have the covalent bond, and we have metallic bonding. Bond. These are all typical examples of what? The interatomic what? Bonds. But when it comes to the intermolecular bond, that is the bond what? Existing between what molecules. This one exists between atoms. This one is existing between molecules. They are weak forces. We have one, the van der Waals forces. You have the van der Waals forces. So these are all for the what? Intermolecular bond. Van der Waals forces. We have the so the van der Waals forces. We look at the landing dispersion forces, and we look at what? The dipole what? Dipole forces. And another one, we have what we call the hydrogen bonding. This is a stronger type of intermolecular force that forms when a hydrogen is bonded to a highly electronegative what? Atom. So the highly electronegative atom, we have nitrogen, oxygen, or fluorine. So anytime you see hydrogen bonded to any of these what? 3 elements, they are highly electronegative atoms. The bond between them is what? Hydrogen bonding. So we can have typical example like the bond in what? In water. We can have typical example like the bond in what? Ammonia. The bond in what? Hydrogen what? Fluoride. These are all what? Hydrogen what? Bonding. These are all hydrogen bonding. So now, in quick, so that we end this particular lesson, the difference between interatomic and intermolecular bonds, which are all chemical bonding, is that one. In terms of strength, we say interatomic is very strong. Okay, so let me do it here so that I get it. So the last one. All right. So now the differences, okay, that in terms of strength, The interatomic is very strong, but intermolecular is what? Is weak. So that is the first one in terms of strength. In terms of function, okay, in terms of function, we say it holds what? Atoms together. It holds atoms what? Together. But for the intermolecular, it holds what? Molecules. It holds molecules what? Together. And we look at the types, the differences as of the types. And here we did it already. We have what we call the ionic, the covalent, etc., and the metallic. And here we have the van der Waals forces. We have the hydrogen bonding. We have the dipole moment. And the last one, interatomic affects chemical properties. Take note, interatomic bond affects chemical properties, and the intermolecular bond affects what? Physical properties of the substance. Intermolecular bond affects the physical properties. So these are things you are supposed to know. When we say importance of bonding, 1, bonding determines the structure of the substance. 2, it influences the physical state, whether solid, whether it's liquid, or whether it's a gas. 3, it affects the melting or boiling point of the substance. 4, it displays conductivity and hardness of the substance. And the last one, it determines the molecular shapes of the substance. So in the next video, we'll be taking them one by one, the interatomic bonds, ionic, covalent, and we'll go deeper into them. See you in the next video.